Okay, so the next line is for you to, it's going to be your homework. G dot dot dot. It's going to look a lot like this other line, A dot dot dot, but no Z and no L. And then I'm going to tell it G40, Z0, and we better tell it G90, or wait, G40, still in incremental. So that'll get you in trouble sometimes. Y minus 0.525. And what this will do is it'll take you, your first hole, it'll take you right back down to the center of your hole so you can wrap it out. You don't want to cut a circle and then wrap it out right up against the edge of the part. You want to feed off of, ideally, you'd want to arc into it and arc out of it, but that's way too much, way too much programming for me tonight. So we'll just, feed in. We're going to helical down, loop it 21 times. Each time it cuts 50 thousandths deeper. And then we're going to G40 out, G41 back in, take one more finish pass, G40 out, and then we're going to wrap it over the other hole. And since we were smart and did all this in incremental, we can just copy and paste it and move on with our lives. Okay, so now I can say G90, put it in absolute, Z.1, and rapid to the same place I was before I started the other helical bore. All right, that looks good to me. I'm sure I'll read it later and find some problems with it, but if you can find problems with this, it's extra credit. All right, so now we need to wrap it over. And even though technically I'm still on 0 here, I'm still at my Y minus 0.990. Since I'm an absolute, had I made a mistake up here somewhere, I want to make sure and give it a Y position just to get me back on track in case I'm off. Just a good practice. X minus 0.5625, and then Y minus 0.990. So I can do this because now I'm programming off the back of the part and the middle of the part because we told it G90, which is absolute. So these two are those cousins that say absolute incremental. And this is a really good, anytime I'm cutting circles like this, I will almost always go to incremental. And mostly because it's super easy to find your mistakes in incremental because all your numbers should be the same. Okay, so all I need to do is copy and paste this right here. So there's my other hole, all done. But we're not done with the cutter because we still need to go around the outside of it. Okay. We are going to put 30,000 chamfers on each corner because parts look way better when the machine does the deburring. It's a little bit more of a hassle for us. Would be cool if we could watch it. I know. Oh, in Mastercam? Yeah. Well, I'll show you how it works in Mastercam because you would go over here and say, I want to start a toolpath. First of all, let's put our plane in the middle here. And a good way to do that is if you pick a point and it turns green, then you pick another point, and then it'll find the middle spot for you. All right, so that's where our 0 is going to be. And I'm going to turn my X to match where my machine X is. And it's not really going to that minus 90, so I'll just kind of type in minus 90. And Another thing you have to do is you have to make sure that your Z is pointing up at your tool, which is pretty important. So another minus 90, enter. Okay, so now I've got this plane. I'm going to call this part 0. And double click. And now when I open my plane manager, it's created a new plane for me, which is really super great because if some of you guys who might know a little bit about Mastercam, if you come up here to transform and you say move to origin, and you change the origin of the part, any other toolpath that you already have up there is going to get destroyed and wrecked. So by using the plane manager, you can create as many different planes as you want all over this part. So I guess it would be logical to follow our part around with this. And that way you can kind of see how it works in Mastercam. Once I have that, I come up here and call up a machine group. I want a mill, and we'll just take the generic Haas. Well, it's a 5-axis mill. Don't need that. And I'm just going to come over here and say toolpath, circle toolpath, helix bore, right there. So this is a little bit faster. I select these 2 holes, and it's going to blast me into, so I just go down the list here. Selected helix bore. These are all the choices. Like if your toolpath's not working, you can say, well, maybe I really want a thread mill, and just click on that. But it'll change. Like circle mill, I don't like circle mill. It doesn't work too great. So we'll pick out a tool, and I like to use the filter button and none, and that way I say just show me the end mill catalog, and I'm going to say, see, we had 3/4. All right, beautiful. Now if I want to edit the tool properties, I'll just double click on that tool, and I'm going to say I really want that thing to run at about 600 surface feet. Well, that kicked up to 3,000, or you can say, well, I really want 1,500. You got a lot of cool options here. Feed per tooth, 0.0026 or so. And then if you wanted to say, well, this end mill has to have a certain length of cut or anything, you can put that up here. And all these comments will get posted into your post processor. Oops, I really don't want that to be tool 294. The nice thing about doing it this way, you can change it on this screen, but if you do it this way and you call this tool out again in your program, it'll retain all these values. We go back here. Okay, we're going to say we want control. That's how we programmed it. If you program where, it'll program the cutter path. If you program control, it'll program the exact geometry. We don't want to leave anything on the walls. Perpendicular entry, so it will turn the comps on perpendicular. 90 and 90, entry and exit sweep. A rough finish, 1 finish pass. We're going to just do a circle at the bottom. I'm trying to replicate just like we programmed it. This is the pitch of the helix. We actually went 0.050. 1 rough pass. You can change your feed rate at the final depth to slow it down, and you can kick up your RPM so you can have a nicer finish. Our finish step over is going to be 0.005. And let's go to linking parameters. Best thing to do here, I'm going to say my depth and just pick it right off your model. So since I left this in incremental, it told it 0. I'm going to turn all these to absolute. So now when I pick my top of stock, it's going to find a nice reliable corner there. That should say 0. Now my depth should say 1.050 now. Minus 1. Oh, it did not, did it? The sun's kind of in my eyes right here. 972. And, oh, you know what the problem is? Our plane manager has not been set up. It's still on plane. Planes. Hold on, I gotta check something. See, it didn't rename my plane for me. It's really, so it's plane. So what I like to do is right click here and bookmark this. Yeah, it's not letting me do the thing here like it used. Oh, I know, I don't have my view sheets turned on. Okay, so now I've got a view sheet here and I can rename it Op1. And I'll rename this Op1 so that everything jives. Oops. Rename Op1. If your planes aren't all in sync, so once you have that all set, you can right click and create a view sheet bookmark. So if I have a bunch of different views, I'll line them all up down here so that I can go across the screen. Say next op would be this side. I'll probably save this file, so as we're kind of programming this, I'll show you how this works. Let's see how it did a weird thing here. It's got the wrong plane. So I need to go back to my toolpath in the parameters and tell it to be op1 all the way across. Op1, op1, op1. So you got three things: your working coordinate system, your tool plane, and your construction plane. So these are usually all the same. The only time when that gets different is when you start doing 5-axis programming and things like that. Okay, so we're going to turn our coolant on, which I don't remember if we even did in our program. All right, so the rest of this is not a big deal. And that made it dirty, so I'm going to regenerate. And so I need to I'm going to shut this window down. All right, because it's doing, when I run this, it's doing my helix bores up here, and it's not going anywhere. That's a linking parameters problem. It's kind of making a triangle too, so let's see what's going on there. So now that we got our plane manager set correctly right here, op1, 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 we'll go into our linking parameters. This is where your, rapids, 1 inch above the part, retract, all that is right here. So best place to pick it is right off. If you click on the box, it'll take you right to it. So now we're at minus 1.092, which is strange because it's only supposed to go to 1.050, but that's probably an issue with the model. So we'll just roll with it. All right, so made it dirty again. So you can see it's coming in here and it's doing one big helix for some reason. Let's just watch it run. I think I programmed it quicker without Mastercam, to be honest with you. So it's going to wrap it down. Oh, it didn't do anything. There we go. So see all these little loops? That's our helix bore. Not real sure. Oh, that's the. So let's post it and see what our code looks like. Now, if you have the Home Learning Edition, you can't do this, unfortunately, because that's the fun part. Uh-oh. Yep. Oh, it's an old file. It's an older version of Mastercam. Usually it will go ahead and post it. I'll tell you what, we'll just save this. Control save. Yes. Not really sure. It went to documents. Oh, good. It went to the bar puller. That's where I went. So we can pull this up. Next next time when we get, or whenever we get the next op done, and I'll show you how it kind of works going around. So control save one more time. Now I should be able to post it. If you pick overwrite, it will let you post the code without having to save it anywhere. If you pick ask, then you have to designate a file location. But I just want to look at it. Not sure what the problem is. Is there no post? Processor thing. Let's see. Usually it'll show you the error and then go ahead and let you look at it. Try one more time and see if I can just pick a post up. Yeah, it's got the 5-axis post. Let's pick a different machine. So if you want to change, say okay, well we only have an Akuma available now. So you can go into your properties and get this set up for an Akuma, which would be good because we were supposed to have an Akuma mill to work on. I can show you what the difference of the code is. Oh, replace. This is where you replace your machine. I happen to have a big file full of machines here. Let's try. How about the Procon Akuma? NOP Akuma, OSP. Here's the one we use at work. 3+4. And notice how it kind of jacks with everything back here. So maybe it'll let me post with that one. Ask. No, I don't want to ask. I want to overwrite. Overwrite. So I'm hoping we can see there's no part revision. That's one of the, something weird going on there. Well, for some reason I'm not able to post it. I'll get to the bottom of that and we'll talk about it maybe next week. But I was hoping that we could kind of confirm that our code is sort of right, but I guess we would slow it down here and you can actually see the action of what it would be doing. So it's roughing it down. If you look really closely at the toolpath, you'll see at the very bottom, if we get it to behave, it's helical down, and then it's going to take one finish pass for the outer circle. So, yeah, it's kind of the free master game. yeah, I like to do the master cam because that's kind of what I've been doing lately. So if you have this loaded, if you have the HLE installed, which I think you can still install, you just click on Mastercam HLE download. You can kind of go through that and download the thing and do it yourself. And it's a lot of fun. All right, so what we need to do now is we need to mill around the outside, which would be basically another toolpath. First, I'll show you in Mastercam, and then we'll do it manually. This will be a contour toolpath, and it can be picky to select a contour on a model like this that has all these fancy edges. I guess we can do it on this level because it's all on the same Z pattern, or the Z plane. So there's a wireframe selection and a solid model selection. So when I'm scrolling over this, I don't have any wireframe geometry. This is all a one solid that was imported, so you don't really have any access to the solid because it was created in a different format. If you're going to pick contours off a solid, put it in solid mode. If you're going to pick contours off wireframe geometry, see, nothing is lighting up when I hover over the model when I've got wireframe chaining selected because there's no wireframe geometry. It's all one big blob. But fortunately, Mastercam will let you It's pretty much the same thing. You select a partial chain, a complete chain, which is what we want. So I'm just going to other face. And I'm going to unselect all those and just go around it manually here because sometimes, so we've got these arrows indicate which direction the cutter is going to be moving. So I don't want it to go around that way because that will be conventional milling. I want it to go around clockwise. So we'll do that. And if I want to chain it to the next line, you can try the next button and it will just zap it on around there for you. Now this is where it gets a little sketchy because it's going to follow this contour in here, which I don't really care. We won't be programming it that way. But to get it to try to pick that all by itself is pretty hard to do. Okay, so it looks like it's done, but it's not. If you zoom in, somehow it jumped the tracks on me. So I'm going to have to just manually do it. The other way to do this is probably easier. Yeah, I want to keep. Probably easier is just make a silhouette boundary of this thing. And so what I'll do is I'll go to wireframe, silhouette boundary. I'll just click on this and it's going to give me a nice wireframe geometry of, see now I've got wireframe geometry. And what I can do, if you want to be really clever about this, I just deselected it. Go to your levels and put it on a different level. Just create a new level. I'm going to call this SB for silhouette boundary. Make sure your green check's over here so that level is activated. And we're going to click on this. And it will do the top view. And green check. So it has created a silhouette boundary, including all of this geometry, whether I want it or not. Since I put it on a different level, I can go up here and turn this off. And if I just want it to go straight across there, I'll just come in there and delete all this noise. Delete. Select all that and then delete. And then I can just create, there's a couple ways to do this. I'm a big fan of modify length. It just creates one nice long line. And I'll trim that so they're not overlapping entities. Oop, what'd I do? So we'll just modify all. Sometimes if you have lines that are just connected like that, it does not like to chain them. So the wise thing to do is go on past and then use your divide delete button to get rid of the trim it off there. Now, I can easily go back into my toolpath and go into my chain and just chain this whole. So, but now I have to tell it, oh, well, I'm going to do wireframe now. I changed my mind. It's going to light the whole thing up. But unfortunately, it's going the wrong way. Easy fix. I like this because this is where it's going to enter. It's going to enter on this corner. So I'm going to say, good to go. And now it puts me back into my tool path generator here. Pick the same end mill. Notice it retained all my feeds and speeds for me. I don't like this plunge rate though, so that means when we say, hey, we're an inch above the part, move Z, it's going to go 6 inches a minute. We don't want that. Retract rate. Yeah, I'll just change it in the tool here. I don't know why I didn't do that. So plunge rate, 50 inches a minute. Retract rate, 100. You're always going to be kind of moving out. We definitely want rapid retract, and this will let us update everything. Definitely want rapid retract, so it's better. Then we're going to go leave that computer. So we want to read our code. We want to be able to read our G41 and 42. This is where your lead in and lead out for your cutter comps. So usually I'll leave this at about 40% on the length. And I like to arc in, so you leave the arc smaller than the line, and what that'll do is it'll turn the comps on in a linear move, but it will arc into the cut. So that way the Haas does not like turn the comps on an arc, because you remember. So we'll take one rough pass at 100 thousandths. We'll take one finished pass at 20 thousandths or even 10. And finish pass at all depth. Keep tool down. Now linking parameters. You can chain your contour anywhere you want. That way you can turn your solid back on. Levels. And you can select how deep you want to be off your model. Which I'll go here. And then I want it to go slightly deeper than that, but I'm going to do it up here on breakthrough. So it's going to add this to my existing geometry. So I'm going to go about 50 thousandths past that. And let's see, we'll go top of stock is 0, feed plane is 0.2. Anything that is set on incremental here is going to be set to the whatever Z value your chain was at. So I'm going to put that to absolute so I absolutely know where it is. And that should be about it there. And let's look at our toolpath. Dirty. And it's programmed it for us. Notice how it's arcing in. So it would turn on G41 here and then arc in, go around it. And it's probably going to do it twice. So we don't want it to go in, turn the comps on and off twice. So you just simply go into your parameters and lead in and say, hey, enter on first depth cut only and exit on last. And then that'll stop that. But you'll have to regenerate it. See how that turned into one line now? So you're not wasting time. Also notice that these are all radiuses going around here. So Mastercam will always do a radius around a sharp corner. And you won't see the radius because it's taking the fastest toolpath available. So I'm going to watch this run, and then we'll manually program it. And then we'll probably have to stop and look at the homework. So I didn't want to bury you guys too much. And there it is, cutting all those nice chamfers for us. So if you wanted to watch this run in a virtual environment, you have to set up your stock. So the easiest way to do this is I'm going to create a bounding box around all my geometry and selection. And if you wanted to make it bigger or smaller, you can do it this way. You can do both sides, both directions. So a lot of times I'll set that up to what my stock really is so that when I'm in verify, it'll give me a real rendition of what's going on there and if my tool is going to crash. All right. I don't think it messed up for some reason. In selection, you can also use the model, which I'll show you in a second here. Let's call that good, and it's doing some calculating. When we go up to verify, it's going to take us to a different screen, which sometimes acts up because there's a lot going on with this processor here. Okay, so I like to stop for a collision. I like to stop for a tool change. I like to turn on my color loop. Each tool will have its own color. And then I also like to turn off the holder so I can see what's going on. So it's going to mill around the outside. I must have only had that one toolpath selected. So if you select the toolpath group, it'll select all of your ops. Verify. And we'll watch it again. Since we're helical boring it, and verify doesn't do a really great job of showing that tool motion. So if we were just, whoa, see, that's a problem. So that helps you figure out, hey, I got a problem here. A little faster. I didn't really see it doing that in the. Sometimes verify is wrong. Oh, there it is. See it? So this is probably an issue with the tool. It's an issue with the lead in, lead out. Let's see if putting that on where fixes it. Yeah, that fixed it. It's trying to compensate too much. So we would have to, this was actually programming the actual toolpath, which is what I usually do. I come in there. It's taking forever. It's like actual cycle time or what? So then it'll just kind of run around the outside of it and you'll pretty much be able to see where it chamfers it. And there's our chamfers, 30 thou. Okay, so back to manual land, 616. I'm going to pause the recording.